new languages, and there are high-level languages in here. And yes, it's very important that you have a language which don't give you the, which does make it easy for you to fail. Because as developer, you're a human being, and you will fail. And that's one of the biggest advantages, that people are inaccurate because they detect so many things by just failing. But you have to also imagine that it's a long history on development, and new languages will slowly be adapted. And only in military projects, or in projects which, let's say, there is time enough to do that, such new fancy things will be introduced. And of course, there will be in the future stronger ADA usage or something. Yeah. But to the second point, I agree with you. Testing is not only testing lies as maybe you would imagine. It's verification, and it's also the kind why it's called verification causes and procedures. Inspection, reviews, and this kind of stuff is a very important part of it. And also it would not give you 10 by the -9 on proof. You also have to involve hardware in that, and you have to divide that by the number of planes which are on the field. So 10 by -9 seems to be quite a huge number, but if you have 1,000 planes, it gets 10 by -5 because you have 1,000 planes in the air. But yes, inspection and review is the one essence, and testing is not just see if it works. And MCDC is much more than just see if it works and it's a black box. We really investigate every line of code, every clause and this kind of stuff. That's why it's getting the effort getting so high.
Yeah, just one other short remark about the automotive industry. Aerospace industry is always seen as requiring the highest levels of software reliability, but that may curiously no longer be true, because automotive industry requires so much software these days. And there was one example. They say that Ford has about 1 million cars per year that have one shared software component that is in all of them. And so having 10 to the -9 reliability may not even be enough.
I can just say from my perspective, I'm also developing reliable software for automotives. First of it, it's funny. In 1995, BMW just announced one of their cars that it contains more computing power that was needed to land on the moon. And yes, we are currently approaching an area where the computers in a car, there are 50 to 80 computers in a car, and they highly interact. But the aerospace industry is just 40 years ahead, and or let's say 30 years ahead. And slowly, the automotive industry just tended to use the IEC 16508 or something. That's a similar standard, but doing a little different approach, like it's more concentrated on fault trees and fault probabilities to close that, and SIL levels are attached instead of software levels, and it's similar. But it turns out that some of the companies are just having a look at the DO-178B, and I'm really curious how that would go on, because currently there is the initiative to develop a better standard for the automotive industry, but it's not here. And it's still a bunch less of software. Okay.
Excuse me, first a short remark. ADA is not a new language, it's been standardized over 20 years ago. But anyway, my question is about something else. Could you please tell anything about software maintenance? I mean, software changes made after certification. Are there any? And if yes, how are they made and why? And how often?
Yeah. First of it, I just mentioned the new other spread-offs and this kind of stuff. Maintenance, that's a very important thing. As you can imagine, you have introduced a lot of effort in just having this piece of software. You may be not interested in do anything else because you finalized, but that's not true. And the D178B just also specifies how you maintain things. And as you have so many requirements, and if you want to change something in here, you have to have a reason. First of it, you may have found a real bug which was not found before, or you have to do something else. And it's also done in a very formal way. By the way, you have to, the whole environment has to be here to reproduce anything on maintenance for 15 years. So the best thing is you freeze your computer somewhere and then you're fine.
So I have a question. This strikes me as a very, I don't want to say old-fashioned, but the software development model is very kind of waterfall. You do requirement, design, blah, 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 blah. Is there any direction in the industry to try to adopt some other kinds of, well, basically cheaper software development models for aerospace?
Yeah, by the way, the waterfall model is I think it's a good model because you just finalize things before you finalize dependent things. Good enough. The D178 does not require it. It just says you have to have a high level standard, a high level requirements before you finalize your low level requirements. That's all. And if you do it in a spiral way, or if you do it in an adapted V module or a waterfall, it's up to you. To be honest, most of the development I've seen currently just using an adapted waterfall model, because it's the simplest thing to use. It's the less effort and the people know it.
Yeah, okay. I mean, I guess it makes sense in this kind of highly controlled environment. And my other question is, I don't really see much role for open source in this environment. Does it exist or get used at all, other than email?
It gets used because what is not stated in here, you can reverse engineer every piece of software you have in here. You just have to take care that the full module, every document is in it. And sometimes they're really using that. Like I've seen an IP stack been used. It has been, yeah, it's not a flight critical system, but it has been used. And it has been reverse engineered and as matter to fit to level D. As a matter of fact, you have to specify, you have to find the high level requirement, what it does, and then you have to test cases, maybe by inspection. That's it.
Okay.
So I think, and there is a company which has a Linux kernel which is fully D178B certified. It has at least the API. Everything else is different, but it looks like a Linux.
What kind of operating systems are you using in the aerospace techniques? I think when you mentioned now the Linux kernel, you were talking about the WindRiver?
No, it's Linux system, but anyhow. WindRiver has a lot of companies have some shares in here. And there are a lot of operating systems. The problem is some components require a really full-blown operating systems, and WindRiver and Green Hills have them. They have fully specified operating systems. They cost a tremendously effort of money, and you can use them. But there are also smaller approaches, like just a time-triggered operating system, which gives you the full functionality you need. They are homegrown by the companies.
Do you have any metrics? What's the actual cost or manpower you require per line of code, per level?
No, because that heavily depends. I was aware that this question will come, but it's really quite simple. If you have a development environment which is used to have formal processes, it costs you almost nothing more than just writing the documents. If you have a development environment which is not used for it, it can put you millions of euros and millions of hours. So it really, you have to have a look at your development environment, how you're used to it, and see if that matches anyhow. Okay, I think we really have to hurry on now.
I have just one remark to the open source question. I read last week at Heise news ticker that Airbus started an open source project, and they want to promote the open source software to use in the aerospace industry. Perhaps you can search at Heise last week.
Mm-hmm. No, I was not very curious. Yeah, it's interesting thing. I mean, open source is the perfect ground which can be used for that, because everything is open. You cannot certify Windows, not because it's not open, but because of several reasons. But
the point is, if you use open source, you have to be always on a level where you don't just change anything, because you have to make a certification of this special version or the special versions of the particular source code files. I think that is a big problem in open source then, because you have to be, the software development process have to be well defined.
But I agree with you, but on the other hand, open source does not directly relate to it changes every time. I mean, there are a lot of modules in the Linux kernel which have not been changed till, okay, 2.6 is maybe different, but 2.4 which has not been changed for years. So if it's good, if it does what it is suspected to do, why change it? So, okay, so maybe if you have additional questions, I will be in here, but so we have to leave the room. Thank you very much.